So if you look at this chess example here, we're looking at bishops, and bishops can only go diagonally. So if you look at the black bishop here, it's stuck in the corner, so it can't go there, can't go down there, can't go there, but it can go this way, as far as it wants, so any amount that far. So like, for example, if you start here, think of it starting in the top right of this box, it can go 1, 2, 3, 4, 5, 6, 7 diagonal boxes, which is pretty far. It's not bad. If you look at the white bishop, it could also go that same direction, but it can only go 1, 2, 3, 4, 5 boxes that way. Or it could also start here and go 1, 2 boxes that way, which, you know, that's not as far as 5 boxes, so that's clearly not the furthest route. All right, now, with this, you can clearly tell that the black bishop can move further. It can go 7 diagonal boxes away versus just 5 here. So, one thing you can actually do is figure out how far away this is by doing this. If you turn this into a right triangle, like this, you could actually measure the distance here. So this is 7 blocks this way and 7 blocks this way, and we're trying to find c, the hypotenuse. So what you could do is 7 squared plus 7 squared equals c squared, which you would get 49 plus 49 equals c squared, and then we'd have c squared equal to 98 when you add those two together. And then all you have to do to solve for c, get the squared out of there by taking a square root, and you end up getting that c is about 9.9. 9.9. And that's basically how far this thing travels. It's like 9.9 units. You could do the exact same thing with the white bishop, except for the white bishop, what you would want to do is 5 squared plus 5 squared equals c squared, yada, yada, yada. I'll save you a little time and trouble here. You would get the square root of 50, which is about 7.1 units. So right there, we can also see that the black bishop, 9.9, travels further than the white bishop of 7.1. Now, another piece on the chessboard is called a knight. It's the one that looks like a horse. A lot of people just call it a horse. And basically what it does is it moves in an L shape. And it can go either 2 units up or down, or 2 units, 2 units in one direction, 1 unit in another. So for example, right here, the X's are all the possible moves. So if you look at it here, he starts here, he goes 1, 2 up, 1 over. Or you could think of it as 1 over, 2 up. Either way, it gets the same place. Or you could go up 1 over 2. Or you could do it in the other direction, up 2 over 1, up 1 over 2. Or you could go down 1 over 2, down 2 over 1, down 2 over 1, down 1 over 2. So hopefully you can realize here that this, in fact, is a trick question, because all of these moves are exactly the same length. It's all 2 by 1. So if you were to set it up here, if we had one equation here starting from, say, this bottom left corner, and we're going to go to this x right here, one way to do that is to go right there. And your right triangle here is 1 by 2. And the length would be your c. So you could set up the Pythagorean theorem with that. And if you did that, it would look like 1 squared plus 2 squared equals c squared. I'm not going to solve that right now because I want to show you that it's no different from finding the distance to here as well. So if we start in that same bottom left corner, if you want, right here, and we're going to go up to this bottom left corner, well, take a look at what this right triangle is. This is a 1 by 2 right triangle. So if you wrote it this way, you could write 2 squared plus 1 squared equals c squared. But let's face it, you're going to end up with the exact same situation. So let's square these things. Hopefully you can tell right now that 1 plus 4 is going to be the same as 4 plus 1. Now we both get c squared equals 5, so then you take a square root on both of these, and you're left with about 2.24 for all of these distances here. So any distance that this knight moves is 2.24 units.